Hi everyone, welcome to the second video of searching and sorting. And here we are going to write a program to find a fixed point in a given array, and we're going to consider both the sorted and unsorted arrays. So let's get started. So let's try to understand the meaning of a fixed point. If you look at this second element of this array, you will notice that the value of element is same as its index, and this is what a fixed point is. So a fixed point is an index I such that I is equal to a of I, and we have to find the same thing using linear search. We're using linear search because it's an unsorted array, so we have to make use of a for loop. Int I is equal to 0, I less than size, I plus plus. And inside this loop, we're going to check or compare if I is equal to a of I, and if it is equal, we're going to store this value of index in a result array, and we're going to return this array. So this is how we're going to make use of linear search to find a fixed point in a unsorted array. So if you click on this link, you will be redirected to this page, and here the question is, given an array of n positive integers, your task is to find elements whose value is equal to that of its index value, which means we have to find a fixed point. And if you consider this sample input, its output is 2, and that's because this array follows one based indexing. So instead of starting from index 0, this array starts from index 1. So this is the index 1 and this is index 2, and the value at index 2 is 2, which means it's a fixed point, and that's the output. So in this question we have to write all our code in this section where we are given an array and its size, and we have to return an array of all the indices which are a fixed point, and if there is no fixed point in the array, we have to return a blank array. So let's start writing the program. So I'll use a for loop to iterate through this array, and because we are using one base indexing, so I'll start our loop from index 1. Less than equal to n, and here we'll check if I is equal to the element at index I, and if it is equal, we have to push this value to vector. So let's define a vector. We can also make use of an array instead of using this vector, but the default was vector, so I did not change it to an array. So I'll initialize it to a blank vector, and after this loop ends, we'll return answer. So if there is no fixed point in this array, it will return a blank vector, or we have to return an array of all the indices that are fixed point. So I'll push these indices to the vector by writing this in a dot push back I So there is one more thing that we need to consider, which is this array. This array starts from index 0, and if you look at this code, you will notice that we're only checking the values of array starting from index 1. So here we are ignoring the value of array at index 0. So to match it, we have to reduce this I to I minus 1. So the first value of this index is compared with the first value of this index, which starts from 0. So let's run this code. So here we have got the correct output, and if I submit this code, as you can see, our program has been accepted. So in this program, the array was unsorted, so we made use of linear search. But in case the array is sorted, we have to make use of a binary search.